I'm Mike. How's it? I work for a company called, before I get to that. My talk is going to be on progressive web apps. For those of you that may have been at Christian's talk a little bit earlier, there will be considerable overlap between the two, but they'll dovetail very nicely with one another. So there's still value. Okay, so please don't get up and leave as soon as you hear me say progressive web apps. I work for a company called BBD Software, which is pretty awesome. They're sponsoring the drinks tonight, yay. Although I think that sends a pretty clear message from like a company culture perspective. So I don't know, use it, don't use it. So I work in the research and development team there, and I don't think I could succinctly explain what it is that I do on a day-to-day basis, but they still pay my salary every month, so I'm assuming it works out in the end. I am also a Google developer expert in web technologies, which I think is basically just a merit badge for the fact that I have spent untold hours apologizing for JavaScript's idiosyncrasies to people. Well, at least that's part of it. And another part of it is that I love and I believe in communities, and I love and believe in the web platform. I think the web is probably the greatest invention of our species, and it enables so much of our knowledge sharing. And this gives me a great platform to say how awesome it is and convince you guys that the web needs to be used. Cool, so moving on from that, I love community, so I organize 2 community events, one that's very near and dear to my heart, the Johannesburg JavaScript community that happens once a month. You should totally come, it's awesome. And then something that's a lot newer to me is the Docker Joburg community that I help organize. And it's also pretty cool, and DevOps is a great journey that we're all on. So if you're interested in Docker and DevOps, please come through as well. But if I were to summarize my entire worldview as a single image with a single word on it, it would probably be this one. So you know what you're getting into, right? Okay, so why are we here? Okay, I think it would be remiss of me to at least cover what progressive web apps are. We mention the name very, very readily, but like, what is this thing that we're going to look at, what we're going to talk about? I'm going to throw a super cheesy acronym at you, FIRE, which we're going to start off with. And I'm sorry, there's only 2 super cheesy acronyms. We'll get through them quickly. So when we say FIRE, what we mean is like, we want to focus on whatever our modern web experience is, to be fast across the network and fast on the page, highly interactive, smooth. We want it to be integrated, deeply integrated into our browser functionality. These things are not just frames to the rest of the world anymore. They do stuff, and we want our modern web experiences to do stuff well. To be reliable, to work when we need them to work, even if we're on awful conference Wi-Fi connections. To be engaging, to be rich and deeply personally engaging from a UX perspective. So that's awesome. And when we dig in, just scratch a little bit further beneath the surface, we see that what we mean when we say progressive web apps is a whole spectrum of characteristics that signify facets of it. But for purposes of this talk, and they're all important, they're all valuable in their own right, I'm going to focus on a subset. So the first one is progressive. It's the big P in PWA, right? And it's nothing new, it's not something we haven't done before, but it's the fact that whatever application we write has to work on whichever browser the user chooses to use. Okay, so we need to be catering for the lowest common denominator as well. It needs to be connectivity independent. Who struggled with conference Wi-Fi today? Like, I'm assuming I'm not the only one. Who struggled with 3G here in these big conference rooms? I'm not the only one. The applications are not resilient in those conditions, and they're not obscure conditions that we're talking about. The applications need to be app-like, because apps are deeply personal to the user, and we want to make the user the first-class citizen in this. They need to be fresh, which I'm not going to belabor on too much, but they need to deliver fresh, new content. And then lastly, which is relatively new to us in the web world, is that they need to be installable. They need to have a native client footprint. So we achieve this with a couple pieces of technology and a couple approaches. And I'm just going to mention them before we delve into any details. So the first one is the app manifest, and this is really the lowest of lowest hanging fruit. And I'm not a native guy, so forgive me if I'm not super interested in this, but this is the part that lets us specify how our application needs to be installed on the user's local device. This is the icon that you use. These are the colors that you use, and this is how I want it to start up. So that's pretty cool, and that gives us the native installable experience, and it's really easy to achieve. The second part, in delving into difficulty, is the app shell. And when we talk about app shell, we're basically looking at taking a native app aesthetic and separating our Chrome from our content and building our Chrome completely distinct so that that can be loaded up on the application as quickly as possible and have our content still be fresh, delivered off the network. The last part, and with any sort of spectrum and movement and philosophy, and we use those words quite a lot with progressive web apps, there is that pivotal technology that is the nucleus of the movement. And that, for our case, is Service Worker. Service Worker is a background worker JavaScript, a JavaScript background worker that doesn't have access to the DOM, but has access to the network stack. And this enables it to access a whole bunch of really new and very modern APIs without interfering with the front end whatsoever. And this lets us do some very cool stuff because it's got access to the network stack that lets it literally intercept network requests and do things like serve content straight from a cache, have content revalidated against the cache and then fetched on the network, or in the ultimate case, deal with offline support where we have no network connectivity and act like that network proxy for the application, which is awesome. So if we take this stuff and we combine it and mash it together, we have our second of awful acronyms today, which is the purple pattern, right? And the purple pattern, it's cringeworthy, I'm sorry, but what the purple pattern implies is that what we want to do is we want to push as many critical resources down the wire to the user as quickly as possible. We want to render that page as fast as we can manage and then pre-cache everything else. And for the stuff that isn't essential for that initial page load, we want to lazy load that stuff. For what I'm going to show today, we're only going to concentrate on the first three characters, so it's more like a perp pattern, although that sounds even more awkward to say. Right. So what will we use? What is going to be in this demo that I've got today? So the first part is we're going to use Angular, but we're not going to build too deeply into Angular. We're going to use Angular as the foil, because remember that the first thing we care about is this thing being progressive. So this application will still have to work for all of the users that are using a browser that doesn't have Service Worker. So we're going to touch on Angular in a very paper-thin manner and show how it fits into this ecosystem. So one thing that I wanted to use out of Angular to just showcase is Angular Service Worker, which is there baked in, well, let's call it affiliated Service Worker support in Angular. But I didn't use it for two reasons. So firstly, it's very configuration-oriented, and I wanted to show a more complex use case. And secondly, it's buggy as hell, and I couldn't get it working. So I'm at least being honest. We're going to use the CLI heavily, but instead of Angular Service Worker, I'm going to rely on Workbox. Now, Workbox is a really, really awesome framework and tool that is basically just dedicated to doing Service Worker stuff, right? We're not going to use any of the build tool plugins, and we're going to use the CLI directly. And something that added some of these gray hairs in my talk preparation was that they went to their final version 3 release 2 weeks ago. So yeah, yes, we're using that version. Moving on from the Workbox aspect of it, we're going to use Chrome very, very heavily because it supports Service Worker. And more importantly, we're going to use the built-in Lighthouse audit reports in Chrome to drive a lot of our decision-making as to figuring out, well, what is this, what can we do, and how do we measure what it is that we do to make this progressive web app? Cool. So where do we start? Now, I work in a really, really cool team at BBD. We were afforded a lot of opportunities to speak into community events. And if you've seen any of us talk, you would have known we care very deeply about memes. We're meme power users, one could say. So much so that we decided to build an app to be able to generate said memes. So if I take a look at this app, you can see that I am a firm believer that there's a Lord of the Rings meme for every possible situation. Jerry is about 50-50 between Star Wars memes and corgis, and Rory, sitting in front, is all about Ron Swanson. So be that as it may be. So this little application allows us to generate whichever memes we want and save them in Canvas. So that's all good and well. Where do we actually start with turning this thing into a progressive web app? So we look at some data, right? I ran a Lighthouse report earlier, and I've got the results in here. I'm not going to run it live because it takes quite a while. But we get a pretty damning scorecard from a performance and progressive web app perspective. We're okay on SEO, so there's that. But what we're going to focus on is the bits and pieces to improve those first two characteristics. Now, there's a whole bunch of detail that it guides you down, but the important one that we are interested in for now is the fact that it takes us about 8.5 seconds on this application to get to that first contentful paint, which is quite a long period of time of staring at a plain white page, all on my local machine. So what we're going to do to improve this, and a lot of this detail is extracted from the Lighthouse report, is firstly create an app manifest because it's easy, create an app shell, right, so we can have some meaningful loading experience above and beyond just a plain white screen, pre-cache all of our essential assets, cache all of our dynamic data and assets, and then finally, which doesn't really reflect at the offline report, but I'm going to do it because it's awesome, is allow offline creation and updating of stuff. Okay, so it's relatively ambitious. There's a lot of stuff that I need to change, and there are some creaky parts, so it might be a hot mess, so I'm really sorry if it is, but we're going to dive straight into it. So if we start off, the first thing we're going to do is look at a very, very simple Angular application, and I'm not going to delve too much into the details. It's not really important. In this context, we just care about Angular as a JavaScript framework. What we're going to do is we're going to create a simple app manifest and call it manifest.json somewhere in our source directory, and as a part of that, we're going to have a whole bunch of JSON configuration stuff. Now, this just dictates stuff like the name, which is meme wrangler 9000, a short name that has to be 12 characters so that when it's installed on the home screen, it doesn't cut off, some colors, whether we want it to display as a standalone application or have a URL bar, because it is just Chrome at the end of the day, or in any of one or two options, our start URL and a whole bunch of icons that, quite honestly, are generated from a website. So not super interesting, but then how we use this stuff is, firstly, we need to ship it with the rest of our application. So if we go take a look at the Angular CLI, we can just specify manifest.json, which is cool. So it'll copy that along with the rest of the assets. And then we need to install the manifest as a part of the index.html that gets loaded on the first page load. Oopsie. I promise I can actually type. And we do that by going link rel manifest. Actually, quite a lot of link rels. And use the relative local path. So if we then, and we need to, because we changed the CLI config, ng-serve, which takes a while. And whenever this is slow, I basically start blaming Meltdown. Right? It was a very, very convenient excuse for when it came out during the talk prep. But either way, it's going to get stuck on 92%. So while we're waiting for this, does anybody want a stress ball? Who wants a stress ball? There's a stress ball. Close enough. Cool, so Webpack compiled successfully. So if I take a look at loading up this application, I just need to zoom out a little bit so I can see stuff. Okay, if we go take a look at this application tab, we will then see that there is firstly this manifest section where it's got all of those details, right? We can see the names, we can see the themes, and we can see a whole bunch of icons that were generated. There's this button that eludes you and promises to add to home screen, but at the moment in this version of Chrome, it doesn't give you that add to home screen experience. So it's pretty weak, and it's going to improve in times in future. Okay, so that's the first part, but if we take a look at what the loading experience is like, every single time I refresh, we've got this long white page. So let's address that. So luckily, one of the nice things about one of the things that Angular does is it uses these custom elements that it then, when it bootstraps, it overwrites with whatever the Angular code is. But that browser just treats this as a div up until that point. So we can put stuff in here, like some simple markup that represents the pieces that might be on this page eventually, and match it with a little bit of styling. I promise I can type. That's super minimal and gets inline, just so that the initial experience when that page loads is firstly showing you something that says, hey, be patient, I've got some content coming, don't panic. So that's pretty cool, and that's relatively easy to get to. So now I'm going to stop this, and I'm just going to rebuild the application so I can get a dist directory and move on to the next part. So those two are really the lowest of low-hanging fruit, right? They're the easiest thing to achieve. It took us a couple minutes. The next part we're going to get to involves us actually creating a service worker. So for our service worker, we're going to use the Workbox CLI, which you'll just install from npm, so workbox-CLI. It's going to download the internet, obviously, and we're on conference Wi-Fi, so I installed it earlier. And then when you use it, you'll be able to just use it like any CLI command, right? And the place where we're going to start with this is the amazingly named Workbox Wizard. Now, I'm not trying to imply that everything is better with a wizard, but that's exactly what I'm trying to imply. Okay, so if we look at Workbox Wizard now, hit enter, you'll see it'll prompt you which directory in your application do you build and deploy, and we're just going to go and say, yeah, that's what I do. Which files would you like to pre-cache? I'm going to say all of them, which is great. Where do you want to save it? Into my dist directory. And where do you want to save the configuration options? And I'm just going to say workbox config, because that's what I've memorized. It spits out a command that you can run to generate it, and I'm just going to generate it purely so we can take a look at what it does. Okay. So if we look, it's created two files, the first one of which is our workbox config. Now in our workbox config, you'll see the stuff that the wizard basically captured for us. Off of generate SW in our dist folder, you'll see that there's a whole bunch of stuff that is the compiled outputs, and then there's our service worker. And our service worker has a whole bunch of comments, imported the script, and of importance, there is this array that it creates, which is the hash version files of all of our Angular bits and pieces. At the end of it, it suppresses warnings, which is always makes you comfortable, right, for generated code. And then secondly, it pre-caches and routes all of those manifests as a part of the service worker functionality. So that's cool, and this is basically as far as the Angular service worker gets you, with some differences. But that's not going to work for what we want to do, which is really take fine-grained control over that layer. So we're going to create a templated service worker. So in our source folder, we're going to create an sw.js. Oopsie. And we're going to do exactly what the generated code does, which is import service worker, have a pre-cache manifest of some kind, suppress warnings as well, because they were over-eager with logging, I think, and then pre-cache and route that manifest. Now, to get this working, we need to update our workbox config to also have two additional items. We need to say, well, where our source service worker is coming from, and what piece of code are we going to find to put that pre-cache manifest in. And that looks as following. You'll see that the injection point, which is where our pre-cache manifest is just a regex, so I can match whatever you want. It's super, super flexible. After this, yes, we now need to install our service worker, because at the moment it's just a file that we generate. And the best point to do that is Angular's main.ts file. So after Angular has spun up and bootstrapped and started the application, it returns a promise. And it's off of that promise that we're then going to hinge. And to do that, we're just going to chain and then into a register service worker method. And this is where we really start installing this stuff. So the first thing we're going to do is we're going to check to see that we're in the, we're in a production and build of this thing, because it doesn't make sense in a debug environment. It's going to thrash and change too much to pre-cache stuff. And the second thing we're going to do is we're going to check if service worker is available and not try and install it if it's not. Okay, and this is progressive enhancement. After that, we're just going to call register on that service worker, and that's it. So what I need to do now is I unfortunately need to rebuild this again. So let's go ng build -- prod, which is great. And then we're going to do a number of things. Okay, we're going to use the workbox inject manifest. Command, and we're going to call workbox config.js. So that's the first thing that we're going to do. Then after that, we're going to call workbox, copy libraries to the dist folder, because we don't want to go fetch it off of the CDN every single time. And then I'm going to use a local server called HTTP server, which is pretty cool. and I'm going to serve up the dist directory, and I'm going to importantly disable the HTTP server's cache, because we don't want it to cache files. So I just go -C0. Now we're going to do this quite a lot, so I'm not going to type that out each time. That sucks. What I'm going to do is in my package.json, I am going to add a simple command that's IntelliSense is not going to work. That is just going to be start SW, and that's going to do all three of those. So hopefully our build has finished, and I can go yarn start SW, and then it'll start our application. Now, I'm going to open this up in an incognito window, not because I'm embarrassed of my browser history, although if I do happen to die, please make sure my browser history is cleared before my wife gets a hold of it. But purely so we get a fresh version of the application. Now, what we should have, if we take a look, we've got our manifest, and if we look at the service worker tab, that's teeny, teeny, tiny, we'll see that a service worker is activated and running and installed, okay? And a whole bunch of Workbox logging notification. Now, when we refresh and we take a look at the network stack, we'll see that those pre-cached assets are being, oopsie, wrong button, are being served from service worker. I shouldn't have done that. I clicked on a thing and I shouldn't have clicked on a thing. No, everything sucks. Damn it. Anyway, you can see that some of the stuff is being served from service worker rather than off of the network, which is pretty cool. And that gives us a whole bunch for really little effort. But we can go further, right? So the next thing we want to do is we want to try and cache all of the data that we access. So this stuff is all stored as JSON data. So for that, we can just build on our, that was unsaved. Don't know how that worked. On our service worker.json, JS, and what we're going to do is we're going to basically register our own routes and provide it with three things. We're going to provide it with either a fully qualified URL, which sucks for this kind of thing, or a regex that matches a URL. We're going to provide it with a strategy, which is either cache first, network first, or stale while revalidate. So either get stuff from the cache exclusively and then check network if you need to, get stuff from the network and then fall back onto cache, or get stuff from the cache and then go hit the network and update the cache, which is stale while revalidate. So categories is relatively stale, so we don't have to, or relatively static, so we don't have to worry about that. And then the last thing is we specify that we're looking for get methods. Now this scales relatively robustly, and we're just going to do that for all of our routes. So the only one that's different is our memes route, which has a regex wildcard in it, looking for which category of meme. And then secondly is we're specifying stale while revalidate for memes because memes update relatively frequently. Okay. But that's not all we need to have the stuff be offline available. We also need to cache our images. So if we cache our images, it's exactly the same thing. We've got a regex that's going to match based off of file extension. We're using a cache-first strategy, but we're specifying a different cache that we want to put this in. And they're all going to be get methods. Cool. So now if I go and rebuild this, I can just run start service worker. I haven't changed Angular code, so I don't have to rebuild Angular, which makes this a bit faster. If I then go to my incognito window and I take a look at the application tab under service worker and then reload, we'll see that there's a service worker that's installing and waiting to activate. That's because the page is already loaded up off of a service worker and pre-cached assets. If it force overrides that service worker, it might be intercepting network traffic and it might now break the user experience. But because it's a demo, we're going to YOLO skip waiting anyway. So when we refresh now, we'll see that the service worker, the new one, is activated and running. And if we take a look at our network, I'm going to need to just zoom out a little bit here, and we reload, you'll see that everything is coming from service worker, which is pretty cool. So that means for the first time, I can now tick the button that says offline, and if the demo gods are pleased, we can have an application that works completely offline. Once I've spooled up all of the data and gone to the, oh, not that one. Once I've spooled up all of the data, I can now offline cache and everything works. And importantly, I can see this stuff inside the application cache storage area. So you'll see that there's a whole bunch of caches, and you can see our meme data all stored there with the actual data underneath it, and our images also stored with their relative sizes, which is pretty cool. So it has a lot of visibility to this kind of thing. Okay? Yeah, and I think that's it. But so the skip waiting is really awful, right? So luckily, we're programmers, so we automate our way out of a job. So I'm not going to skip waiting. I'm instead going to add an event listener onto the install lifecycle that's going to skip waiting for me. Now, this is obviously an awful experience, and it works in this example. But if we actually had users, it would be infuriating, potentially. So the better thing to do would be to use the broadcast API that Service Worker has access to notify the front-end thread to say, hey, cool, there's an update available. Prompt the user with a toast or something saying, do we want to install updates and reload the application, and give them the choice, right, because they're king. But that's quite a lot of code to write, and, well, I'm going to skip past and do the more fun stuff. I hope you don't mind. So what we're going to do is we're going to go onto offline support, okay? Purely because it's a thing I've been asked to do in the past, and I've always said no, because it's an insanely hard problem. Not with Service Worker, which acts as an intercept layer. But if we use it as an intercept layer, oopsie, that was the wrong number. Yes, sorry. So to be able to intercept offline updates, what we want to do is we want to use a different API that Service Worker has access to, which is the background sync API. Now, we're still going to use Workbox to wrap around this because not all browsers like Firefox support the background sync API yet, and this gives us fallback support with that. But basically, what the background sync API will do is it'll write to a local index DB, and then based off of browser heuristics, when it reconnects, it'll push those changes back to the server. So the first thing that we do to initialize the background sync stuff is we create a Workbox background sync queue, which we're going to call memes to be saved, and I wish that was it, but unfortunately it's not. For this to work, we have to basically take over the network stack, which means that we're going to add an event listener onto the fetch aspect of Service Worker, or the fetch API, which is basically all of the new Ajax stuff. We're going to listen to the event that comes through, and we're going to match the URL to make sure that it's a memes URL, and particularly a post method. Then inside there, we can start playing with that actual network request. And when we play with that network request, we can do we need to resubmit the request on behalf of the network stack because we're choosing to intercept it. So we call fetch on that request. Importantly, we clone that request because the new APIs, specifically the fetch APIs, are designed to be immutable. So you can't manipulate the state, and you can't reuse the object. If you want to use it, you need to copy it. Otherwise, you get weird results. So we clone that request, and we submit it. And if something goes wrong, we'll add a clone of that request to the queue, and background sync will take care of it. Right? It's as easy as that, right? Unfortunately not. As we well know, there are two hard problems in computer science: naming things, cache invalidation, and off-by-one errors. We're unfortunately in the realm of cache invalidation now. So what we need to do to actually get this working is we need to submit the request ourselves for the network stack. Then if the response is successful, we need to invalidate the cache. Then if the response has failed, we need to queue that change up, which also implies manipulating the cache. Now, before I go any further, I need to apologize because these APIs are all, the Service Worker APIs are all designed to be non-blocking, which is amazing. But that means that literally everything is a promise, which means that we're in the realm of callback hell. Okay, so you'll forgive me as we go through this. To invalidate the cache, what we're going to do is we're going to get the request in, we're going to read that request JSON, then as a promise, and then when that's done, we're going to open the right cache by name, then we're going to try and delete it based off of a URL that it'll match, computed off of the data in the request, and then because we're intercepting network traffic, we still need to actually return a response. So the successful response that we get back from the network, we pass through. And that's pretty straightforward. But then the last one that we need is to queue our change. And this one's a lot heavier, right? So the simple part is adding the request onto the queue. Then we read the request data. We manipulate it so that we can annotate the offline data to say, well, this stuff isn't persisted yet, so use it differently. And that's important because we need to inform our users that the state is potentially inconsistent. We then open the right cache. We match that particular URL against the cache. We read the response data. We mash the two arrays together to make sure that we've got a consistent view of what the user is expecting the data set to look like. Then we need to create a new fake response. We need to then put a clone of that fake response in the cache, matching that particular URL. And then because we're intercepting the network stack, we still need to return a response, right? So then we return a clone of that response back to the network stack. Now, if the stars align and the demo plays nicely, we should be able to rebuild that, go to our application. Now I'm going to go to the Service Worker tab. When I reload, you'll see it's on number 4. Number 8 will should install and update. Who was that? Who was that? Who said offline first? The swag is predominantly for people who catch mistakes that I make. All right, so Service Worker number 9 is now installing. We can see that it overwrote it and it pushed its way to the top. After that, we can now make sure that everything works on reload. Everything's cool. When we go here, and we specify that we want to operate offline. Sorry, before I do that, I just need to load the load the images, yeah? So we're going to use survived. Let's use survived. Survived seems like a good one. We're going to go offline, and we're going to say, I survived an offline first demo. Hopefully that's true. It's going to be embarrassing if it's not, right? Okay, so I'm offline now. Let's clear the console, and when I hit save, a whole bunch of stuff will happen. Okay, now we're going to look at what's happened. Firstly, at the top here, we'll see those green log requests. It says that background sync has added something to the memes to be saved queue, okay, which is the first clue that we have. The second clue that we have is that if we refresh our IndexedDB, there is now this Workbox background sync queue, and we can see that one item in the queue. The last part that we've got is we can see our demo or our meme that we created in grayscale. And that's because, remember, I annotated it with that offline equals true. I snuck a piece of code in the application that will render it on grayscale in the canvas if it's offline. And this is really important because we want to communicate state effectively to our users because we're getting them to deal in this inconsistent state realm. Great. So that's awesome. And if we reconnect, at some point in time, based off of its own heuristics, the browser would pick up that request and resync. Possibly later when they reopen the browser, possibly at a periodic time check when they've decided to see if there's network connectivity. It's highly variable. Now you can put in a whole bunch of code that will, on Service Worker startup, when it reinitializes, do the syncing for yourself. But just to demo it for purposes of this, we're going to use Chrome's tools, which is the sync API that we see at the bottom. So if we go back online and we enter the Mystic incantation, which is Workbox background sync : memes to be saved. Let's clear that. And we push sync. We'll see that the sync API says that that request has been replayed to the server. And on our IndexedDB, if we then refresh this, we'll see that that request is dropped off of our local IndexedDB, all on your local machine. Now, we specified stale while revalidate as the memes cache strategy, right? So that means that it'll fetch from cache and still get the old data the first time, but the second time it'll reload. So if I hit reload, it's going to show us as gray because it's fetched from the cache. And if everything works, sure, okay, great. So I think that's it. I think it's working offline. So we can use it in this conference venue, basically. So, and this is a common scenario. We need connectivity tolerance for situations like this. We work in an old 80s era building, right? Which I swear the walls are lined with lead, so when the spotty Wi-Fi, I'm not looking at Tony, when the spotty Wi-Fi goes down, we can't even fall back onto 3G because of the lead-lined walls. Okay, so let's mark our own homework, right? So we started off with a pretty dismal result. And if we take a look at where that goes from now, rerunning it afterwards, we get a much improved performance score and a much improved progressive web app score. Importantly, remember we had that awful time to first contentful paint. We've brought that down from 8.5 seconds down to 2.3 seconds, which is still pretty, it's not amazing, but it's a big improvement considering we've spent 35 minutes at this, right? The report still has a whole bunch of stuff in it, but these are now heavier items to address. So what are the next steps? Where can you go from this? So the first thing you can do is, like with Angular, I used Angular material, which is really heavy. So our vendor bundle is really big at like 600 kilobytes. We can remove some of the dependencies that we don't, strictly speaking, need, code it yourself if you can, and then just shrink that down and you'll implicitly get a better time to performance. We can use progressive images, much like Christian mentioned in the previous talk, where you can start off with a really low-res image or an appropriately raised image and then scale up any of a number of mechanisms. HTTP server locally doesn't have text compression on it, so if this were deployed to a proper web server, it would perform a lot better. And then the last one is code splitting. If you've got a larger application and have like an admin section as a part of it, use code splitting to make sure that you create a separate bundle for that and then lazy load it into Angular. But that's a whole separate talk on its own. Okay, so in summary, why should you care? Okay, if the Christian's talk on the next billion users didn't make you care, and the performance arguments that we saw now on getting time to first contentful paint really, really down didn't have you care, and the offline didn't have you care, then I think you might be in the wrong session. The fact that there's 2 talks on this topic at this event, the fact that these libraries are all coming out right now, this is a very, very big deal, and it's a very, very big thing. It's the way that web development is going. And it all adds value. So there's a part of it that's philosophical, and there's a part of it that's technological. So climbing to the part that's technological. Is this thing ready? So you've seen it working in Chrome, right? Awesome, great. It does. It works really, really well in Firefox. Some of the APIs that they're a little bit more stringent on, like background sync, are not perfectly implemented yet, but that's why we use Workbox as a fallback. Edge, the Edge team is committed very, very heavily to this, so much so that they're going to use Bing to scrape all of the progressive web apps they find and add it to the Windows App Store. I think that's primarily because there isn't anything in the Windows App Store. Sorry, is that too harsh? Sorry, Microsoft people. And then the last one, the big elephant in the room that's preventing iOS support, is Safari. Now, I know that they've shipped service worker support in the latest Safari beta, and hopefully by the next version of iOS, we should have service worker supported in Safari, supported on iOS, and the stuff will move forward really rapidly at that point. So we feel like we're very much on the cusp of this big movement. So if I may have any questions, if there are, please feel free to ask them. I've still got some stuff to give away for good questions. Yes, can we get the microphone? And please submit the speaker rating form if you guys wouldn't mind. It's great to get feedback in this kind of a venue to figure out what we can do better. I have a reputation of getting feedback to wear shoes. That's not going to happen. I'm sorry. But feel free to go ahead. And then finally, can we get the microphone? Microphone in front here. Oh, is it? Frederick, are you going to? You can ask me questions on Monday. Or maybe not on Monday because it's a public holiday.
Hi, Mike.
How's it?
So I noticed you built the app with ahead of time compilation.
Yes.
Had you not done that, had you not built it with AOT, would the performance be different?
Yes, absolutely. Because if you don't run the Angular application with AOT, you're shipping down the whole Vue compiler. So it will build the template compiler at runtime, and that'll take a whole lot longer, as well as be a whole bunch more to download. So your time to first contentful paint will be worse. So from an Angular-specific perspective, they're doing a lot of work on the Vue compiler, and now, like end of March, beginning April, they're expecting to release the next version of Angular, V6, and hopefully there'll be the first preview of what they've called their Ivy Vue engine. And with the new Ivy engine, they're going to take that 600 kilobytes or 300 kilobytes for a bare bones application all the way down. So hopefully there's good things coming there. But yes, you're right. It would have affected performance.
Sorry, just another question.
Yep.
So I've just lately been toying around with the Firebase ecosystem. And there was one flag that I noticed called enable persistence. So I'm not sure how it relates to this. It's probably completely irrelevant, but I've noticed once that after I've enabled that flag, the application was sort of like worked even though it was offline. So
Yeah.
I was just trying to make connections.
Is that the
between what you just
Firebase API?
I beg yours?
Which API is that?
The Firebase.
Firebase.
Yeah.
So I'm not intimately familiar how it works. I can double check for you, and I can maybe give you an answer at the cocktail event later. But I have a suspicion it uses Service Worker to be able to do that. Come grab a thingy for good questions. Yes, Mel. You can also ask me a question on Tuesday. You can ask me one now. But nobody else can hear you. Okay.
How about now? There you go.
How about
Okay.
now?
So being in the mobile space and some websites, there is still a loading spinner. Why would you get rid of that? Like a lot of users feel comfortable with the loading spinner, right?
Who feels comfortable with the loading spinner? We're not going to judge. Put up your hand. Okay, so there's like 4 people, right? Those days have passed. Don't make me waste my bytes downloading something that's adding no value to my life. And a spinner doesn't add value. Rather inline something that gives me a more meaningful indication. And it's something that we as web people have been traditionally very poor at. And when you look at particularly using a native aesthetic, none of the native apps load up spinners, right? They, if you look at the Facebook app, that's a great one, if you haven't uninstalled it. If you look at the Facebook app, it shows you where they're going to put content, where your icon is going to be, and they've got some animation there. So it's not to say don't take away animation, it's just to say a spinner isn't necessarily meaningful. Okay. Anyone else? There's a question back there. Okay, Mel, you've got the conch. You can walk it there. Oh, okay.
Mike,
How's it?
where do you see the comparing this type of apps with hybrid apps in terms of popularity? Which one do you?
Perfect. Okay, so that's a good answer. It's not relevant for this talk, but I gave another talk at the developer user group earlier in the year where I spoke about why you should care. And this doesn't, I don't believe that this affects native. You'll still build amazing native applications, right? Where I think this plays is in that middle ground. So hybrid apps, I think, are particularly challenged going forward. We're not going to build Cordova-based solutions, nor should we, right? Why should I download Cordova when I can have a couple 100 kilobyte thing that works on the same phone that Cordova would work on anyway?
Sure.
Okay, awesome. It's T-Setso, right? Is that Mr. T? Okay. There you go. And I actually hit with that one and you couldn't catch.
Hi, Mike. Just out of curiosity, if this works so well with caching and progressive web apps, why wouldn't people just use this in general? Like even your normal browser caching is somewhat inefficient. Like why would it have to be a progressive web app? Why couldn't I, if you have no internet connection on your browser and your desktop, still use the cache? Why wouldn't you do that?
Totally. That's the point,
Okay,
right?
good. So people shouldn't necessarily categorize this as a PWA solution. You might as well just use it in general then.
Well, PWA is a little bit of a buzzword, right? That's just one technological aspect of PWA that enables something really awesome. So traditional browser caching is really difficult to tweak to reliably work in that scenario. The service worker is just so much easier. So in short, yes, you're right.
Okay. I think all of this should work under HTTPS. The addition, the at-home screen won't work, and the other stuff, so the stuff that's coming, the other APIs that they're adding into, because service worker is privileged, right? It's got access to a whole bunch of cool stuff that won't work under HTTPS.
If you were going to Jerry's talk after this, she talks a lot more about the stuff that Chrome is, or the new modern browsers are specifically excluding based off of, accessing not on HTTPS, which is good. Everyone's site is on HTTPS, right? Right, everyone? Okay. Christian. Oh, Ed, yes.
Regarding security, there is both and well offline, but in terms of SSL, when we are doing the SSL handshake,
Yeah.
we've broken the connection pipeline because we are offline.
Yeah.
How do we handle that when we are resubmitting later on, so there's no more TLS
Sure.
going on? And also, if it's session-based, there are tokens that expire.
Completely. So the first part, let's talk about the SSL bit. So you must remember that this acts like a reverse proxy for your JavaScript layer. So it hasn't hit the network stack yet, so it hasn't started an SSL connection. So it's caching before it even tries, which is why you can do all of this magic. So SSL, mutual SSL, hectic SSL doesn't break this. However, the tokens would. Because remember, we put the whole response message that we were faking inside the cache, and we tried to replay that. If you tried to replay that later, if your token authentication was worth anything, it would bounce that and say, no, your session's invalid. So it's a very, very valid point, and it's something to keep in mind, something to think about. Christian.
Yeah, so this is on.
It takes a while.
Yeah, I'm not sure it's working, but this is just going back to account sync. So I'm just worried, like edge cases where you've already given the user the impression that this worked by rendering a UI of what has been sent to the server, and then down the line, the request failed. So like this is a scale situation. Payment.
Yeah.
So like you try to take payment offline, and then you initiate a payment request, and then you cache a request and tell the user, okay, payment was successful, stuff like that, and then
Yeah.
at the end of the day, payment doesn't work.
So that's a perfect example. So I think with this kind of thing, firstly, like the answer is always, it depends. Just because you can save stuff offline doesn't mean you necessarily should. So for a payment, that's a pretty extreme case. You might want some guarantee before delivering something. But then failing that, if you're trying to take payment and you're not actually delivering a service, but you're rather reserving something, you could queue that completely safely. And if your server-side stack was tolerant for network disconnections, it could take that request and then service it behind the scenes. And you still tell your user, listen, your request is pending. Don't worry, I haven't forgotten about your order. I'll get back to you. And if you have any further questions about that, the person you need to speak to is sitting in the front row. Wave, William. He knows all about that stuff. So I think you would complement that scenario with good server-side architecture for like an event-sourced system. Does it make sense? Yeah. But communicating state is key. Okay, so I think I'm out of questions before I'm going to eat into more of William's time. Please feel free to come catch me in the corridor later if you want, and thank you for being awesome.